Welcome everyone. My name is Ahmed Momani from Jordan. I'm working in the Jordan uranium mining project with the Jordanian Atomic Energy Commission. I'm so glad to attend in this training course with you. In Jordan, we have facilities may in future or will in future need to decommissioning works. And these activities will cause us to need it for environmental remediation. So, in my country, in Jordan, there's a limited resources, but we are working closely with stakeholders to achieve the best practice. So when we talk about the challenges, for example, not limited to. This example for the challenges they will facing when we are working on the decommissioning and environmental remediation. Firstly, with the technical, for example, to providing expertise and the skills for the environmental remediation and the decommissioning in the future, and to develop the planning for this. We have a regulatory body in Jordan and doing well, but every time we have to improvement for these plans to be fit when we are needed, like in developing the ongoing plans. And for some specific challenges, like providing the materials and equipment with the limited resources in our country. And like the financial, this is the four challenges. As what I say, we have a limited resources, and we facing a problem every time when with the social acceptance, when we are dealing with any nuclear activities. So it's a challenges, and in the last challenges, the environmental, to doing the environmental impact assessment need resources and its cost. So when the limited financial resource, it's a challenge. So for Jordan to addressing these challenges, we require to adopt a comprehensive approach for included the capacity building, stakeholders engagement, and international cooperation. Thank you.
Any question for Jordan?
Yes.
Is there active opposition to nuclear power in Jordan?
Active position, nuclear power? No.
Opposition.
No, there's no nuclear power. We have a reactor, a research reactor.
A research.
Yeah, and have a decommissioning plant reactor. Another question?
Just one comment that
Yes.
you put in your presentation. You said we might need decommissioning and remediation. As I explained, we will need to decommission.
Yes. No, I'm sick.
And hope that remediation will be minimized by good practices. Yeah.
Thank you.
And the agency has a document called Milestones for Uranium Mining that you can take a look, because it defines all the milestones that need to be taken into account in the development of uranium mining process.
Thank you. Other comments? Thank you.
Thank you very much for sharing.
Thank you very much for this time. I'm Adi Wijayanto. I come from Radioactive Waste Management Installation as Radiation Protection Officer. I'm going to talk about the experience and challenges of Indonesia on decommissioning and environmental remediation. We have experience in our country, Indonesia, and there is contaminated land caused by artificial sources from industry, cesium-137. This open source code. And we also have experience to clean up and make remediation, environmental remediation. After contaminated, we moved to radioactive waste incineration, and we research reformer used as a tennis court. We also found the activity concentrate around 9 times 10 power 4 until sorry okay 9 times for becquerel per kilogram to 5 times to 5 becquerel per kg, and then to be 10 power 3 becquerel per kg after environmental remediation. The first stage, mapping. We make mapping using some software and detector, and then coring to the land, and then the thirdly is evaluation in the area, and then land dragging using excavator, and the last stage is transport to radioactive waste management. And the waste is 904 liter 200 liter drum. So in this current issue, we would like to choose technology how to manage radioactive waste soil, and we have conducted phytoremediation to use to remove contaminant from land, soil, and then the challenge. Also, we have built a decommissioning program, but we would like to know the aspect about the challenges, comprehensive decommissioning planning. We would like to know further more about this decommission program, and I expect this training can give me to knowledge about this program. And then the second one is cost estimation, cost and those, and also cost and benefit estimation. I would like to expect in this training I can also get the cost estimation like this board. And then technology used to decommissioning. Also, the challenge we would like to know about the technology that use robotic or AI to remove decommissioning. And then the last communication to the public, dissemination to the public. We would like to know how to the effective technology on how to how to communicate to the public. And we have planned to decommissioning. We have 3 research reactors in Bandung, Serpong, and Yogyakarta. And we also have planned to decommissioning and environmental radiation to Bandung research reactor. And also we have radioisotope and radiopharmaceutical production installation. We'll be doing 10 in nuclear cell facility and also nuclear fuel fabrication. So we have big plan to decommissioning program in the next in the future. Thank you. Yes. Any question?
Can you go back to your first slide?
Yes.
Okay, you did the mapping,
Yes, mapping.
right? We go there, and then you did the coring.
Coring.
Yeah, the coring was to respond to what question?
To take sample, dig the sample how deep, and then we use gamma spectroscopy, and we calculate. We estimation the concentration, activity concentration. So if we get the value, then more than one time 10 power 3, so we moving the soil into drum, 200 liter drum, and then move to radioactive waste management installation.
And what was the depth that the season moved?
Around 1 meter, 1 meter and 1.5, and so the last covered by concrete, cement concrete cover, and then right now used for tennis court.
Right. So you're telling that the season migrated 1 meter?
1 meter, around 1 meter.
Homogeneously in the whole area, or just?
Sporadic, like hot zone and the different point.
And what was the form season?
There are cesium, dry, semi-liquid, cesium.
Oh, okay, it wasn't liquid.
Yeah.
Okay. And then you say that you moved the material to storage facility.
Storage facility, interim storage facility. We have collected 900 gram, 200 liter grams.
Right.
Yeah.
And what is the plan for the final disposal?
We would like to make remediation. We use in the pool. We have pool. We would like to spread the soil, and then we choose the plant to remove radioactive contaminant cesium into the plant, and then plant we would like to manage by incineration and maybe compactor.
So you take the plant, you will incinerate the plant?
Yeah, we have the plan. We already have conducted the research on remediation that I tell you, remediation to remove contaminant from the soil.
So you've already done the phytoremediation?
Sorry?
You've already done the phytoremediation?
Remediation only research scale. So we would like to make the big scale up. Yes.
Okay.
Okay.
Thanks again.
Thank you very much.
We go now to Iraq.
pleasure to attend the first training course. I am from Republic of Iraq. My work in Iraq Atomic Energy Commission, working in Decommissioning Directorate of Nuclear Sites and Facilities. Decommissioning Directorate, I am working in the reactor research site, ART 5000. The name is in Iraq, 14 Tammuz. My job is Senior Chief Engineering. I am Assist of Decommissioning Manager. I am Mechanical Engineer. Scope of my work is preparing and implementation decommissioning plans on site. In Iraq, we have just in Baghdad, we have 11 sites, nuclear sites. We are in a special case because most of our sites is pumping, so we have decommissioning the most of them. Till now, we are 3 decommissioning sites, the G-Pilot sites and Lama sites, and we are working about the ART 5000. You can see it's before pumping. It's the first pictures. And the second pictures about after decommissioning part. In the decommissioning part, we are just one, we have decommissioning the cooling certain, cooling tower, and the building of staff. And the next, the remain the pool. The strategy of our country is to save enclosure. So we can't decommissioning to this site. So we help from IAEA to approval to save enclosure. So we submit our plan to the regulatory body in our country, so to the submit to the IAEA to help in this decommissioning. Okay, and we are knowledge in our sites planning and the project of management for decommissioning of nuclear sites. We have a good experience when we are decommissioning 2 sites before. And cost estimation, we working about cost estimation in every site of the nuclear site and how the labor, materials, transportation and waste disposal. So we have advanced in risk assessment to the workers and the environmental assessment. So we have the directorate specialist to the waste management to reduce the waste from, it is the result from decommissioning the sites and clear our it's a clearance for safe materials such as like material and concrete. And we are, in some sites, we are continuous monitoring to ensure there's no time on waste or hazard of radioactive contamination. This is my work and my job. If I have anyone question to me about the sites in Iraq, it's my pleasure to answer you.
So I have a question. You mentioned that the strategy that you consider is safe enclosure.
Yeah.
And why you do?
Because we can't have the technical tools and we have no financial arrangement to this. It's the high cost. So we take this decision about safe enclosure just inside the reactor research ART 5000.
Mm-hmm. So the decision is driven much more by cost.
Yes, just on cost, and we have lack of experience in this site and lack of financial matters. You know the Iraq in the special case.
I know. I worked with that.
Okay, we worked it.
In the beginning, in my career then. Okay. Are you all familiar with the meaning of safe enclosure? So maybe needs an explanation here.
Okay.
So there are different strategies for decommissioning. I'm not a decommissioning person, by the way, but after working some time, we learned. So you can have immediate dismantling as a one option, deferred dismantling, that you put it at the more
time.
you give more time to decay the short-lived half-lived lights, and the safe enclosure, which is also sometimes called by entombment, is that you make a kind of a cover in the reactor and you leave it there. This is not something that the agency really encourages, but I'm not sure the situation as it is, but that would guarantee that the reactor will not be exposed for a reasonable period of time. But eventually you will need to take care of the reactor.
Yes.
From
Because we are decommissioning all the sites and around the reactor pole. Just in reactor pole, this is remain.
Oh, just reactor.
Just reactor pole. So we have decommissioning the ventilation rooms and cooling sorting and tower cooling. So this the final just full of reactor research.
Which is more contaminated area.
Very contaminated. We don't have any technologies. Some of one opinion is about to buy reports to decommissioning. So this is the final decision is safe enclosure for low cost, and it's safe to everyone in this intuitive site.
Okay, good. Thank you.
Thank you. Merci.
Okay, so let's see who is next. We go to Russia.
Hello everyone. I'm glad to be here and thanks for this opportunity for me. And I'm Anastasia Shitova, I'm from Russia, and I work as junior researcher for Burnazyan Federal Medical Biophysical Center of Federal Medical Biology Agency, Department of the Public Relations Agency. I prepared little information about participating our department in program. This program named Remediation of Territories of Eurasian Economic Community, member states affected by uranium mining operations. Mostly there are Central Asia countries in program, and our department of the Public Relations Agency is working to assess the impact to the population of the facilities on the population, and also we are working to carry out monitoring during the remediation process, before, during, and after remediation process. I can't tell about all challenges because we are carrying out only monitoring, but I know that In this case, before this program was started, there was problem with environmental awarenesses of people who are living there, and which led to increase the external exposure for people.
I'm noting everything you say, so tomorrow you will see a nice graph with all the challenges you are looking forward to.
So,
Thank you.
question.
Questions for Anastasia.
Anastasia, question for you. You mentioned about these.
Sorry, Forrest, can you maybe use the microphone?
Yeah. So let's agree that you use the microphone here, and I use this one. So this is better. So the question is, you mentioned the Eurasian Economic Community members. What are these members that you're talking about?
Republic of Kyrgyzstan, Uzbekistan, Tajikistan, and Kazakhstan, and Russia.
Okay.
But we are working only Kajasai, Minkush, Tabashar. It's all. Yes.
Okay, but there is a work done also by the European Commission in those countries, right?
Yes,
And
together.
your work is in line with those efforts?
Yes, we work together with. Rosatom is working in these territories, but we are providing only monitoring.
Oh, you are just focused on one?
Yes.
Oh, okay, understood. And did the monitoring show any trend or any variation in the parameters that you are measuring?
There is a big problem with radon, escalation of radon, because people who are living in this territory have access to a site. It is not restricted, and they also used before this program used materials from the site for their buildings.
Okay.
Yes, it's leading to increased external exposure at the time.
So the problem they have with radon is mostly because they are using the materials to build.
Yes, their houses. Yes, that is why I mentioned about environmental awarenesses of people.
Thank you. Any other question?
Let's go into the first. We have a presentation here from, I think it was virtual.
We'll come later.
We skip that.
Check this one.
Okay. So then let's go to Egypt.
Hello everyone, I'm proud to begin this event in Armenia. My name is Sami Hindawi, I'm PhD in chemistry, material chemistry from Egypt. I'm working at the Nuclear Material Authority. My experience at nuclear nanomaterial sciences and characterization and applications. I have 22 publications on advanced materials for environmental remediation, anti-radiation shielding and waste management, focus on nanomaterials, catalysis, ion exchange. Decommissioning and environmental remediation. Decommissioning and environmental remediation. We talk about management of legacy site from past uranium mining and mining activities, and the decommission of contaminated areas around research reactors, and disposal of radioactive waste from medical and industrial application. My sustainability and circularity experience in developing eco-friendly materials for radioactive liquid waste management and researching technical solutions for nuclear liquid waste else degradation, innovating the sustainable radiation shielding materials, free lead materials. Thank you.
Questions?
Yes. What you are talking about? You're talking about developing eco-friendly nanomaterials for radioactive waste management.
Yeah.
Would you be more specific of what type of nanomaterials and what is the application?
Okay. For liquid waste like materials, we try to develop new materials like metal oxides or cytosol, which have more surface area and more active site to absorb radioactive ions from its liquid or make oxidation or reduction for uranium from its liquid.
Okay. And then once you have these materials, you are reducing the volumes, I guess, of weight of
Yes.
waste. And then what is the next step?
For gas?
For gas, no. For you are using nanomaterials to remove the
By illusion.
flies.
By illusion. Illusion from ions. When metal ions absorbed in the nanomaterials,
Yes.
we after that elute it by some acids or alkalides.
And what is the final destination of the waste? You still remain with the waste.
Reserved for another research.
Oh, you will
Yeah.
apply the. Okay.
And this nanomaterials also we can develop in free lead shielding materials like zirconia, titanium. Question?
Thank you.
Thank you very much.
Yes. Hello everyone, my name is Muhammad Ikram, Quality Assurance and Quality Control Engineer for NAPPA, the owner operator of the nuclear power plant in Egypt. Is the first one. We already have 4 units under construction of EPC contract with the Russian party. My area of expertise, developing integrated management system, inspection, testing, localization, corporate social responsibility and sustainability, and governance, risk, compliance, continuous improvement. Overview about our project. The DAWA project consisted of 4 units, VDR 1200 reactors, using to construct under the terms condition under the EPC contract with the Russian parties. In March 2019, the site approval permit for the DAWA nuclear power plant is issued from our regulator. Construction permit were issued from our regulator for all units. The first concrete was poured for all 4 units for the DAWA nuclear power plant. The last one was in 2024. General fundamentals principles, I quoted it from IAEA Energy Series NWT 1.1. Those principles starting from safety of current and future generation. NAPPA developed an integrated management system according to general safety requirements, part 2 of IAEA, that integrates quality, safety, financial, economical, social responsibilities factor to ensure safety of the current and future generation. The second one, ensuring a simple preservation of resources, financial, technical, scientific resources for decommissioning. NAPPA already developed a contract, signed a contract with the Russian party to support construction, operation, and spent fuel management later on, and even decommissioning. Finally, intergenerational equality, according to each generation incurs long-term liability should be responsible. So all decisions taken now are considered in our management system, considering the not overburdening the future generation with extra liabilities. through the framework established in integrated management. Thank you.
So, question to you, if you go back to your slide, you are ensuring a financial conditions for the decommissioning. Do you have any clear approach for that that you are aware of?
Okay, according to my information, we already have a continuous funding for our project, continuous supply. We have a loan from government to government agreement with the Russian parties to support the construction, commissioning, operation and maintenance later on, and even supporting our spent fuel management, radiation protection, environmental monitoring through a loan will be created from the government of Egypt to the government of Russia.
Okay. And the plan is to get the spent fuel back in Russia?
No, spent fuel will be in Egypt. Our strategy for spent fuel management is wait and see. It will be after spent fuel get out from the reactor. It will be for wet storage and then dry gas until taking other decisions. But our waste will be in Egypt. Will not be sent to Russia. Any questions? Yes.
In your country, do you?
So, thank you for the presentation. It was very interesting. Spent nuclear fuel, do you accounting that like radioactive waste or it's not waste?
Okay, I'm not specialized in the nuclear fuel management, but according to our management system, we already have a process for fresh fuel management, another process for radioactive waste management, and another process for radiation protection and environmental protection. So it's treated in a separate manner, but they are interrelated and interactive with each other according to the processes which in our integrated management system. So I'm not specialized in radiation protection.
And one comment, just be very attentive when you will develop the commissioning plan, because during the decommissioning you will have a lot of waste, different classes of waste. So you have to think about also and put some correspondent financing to your.
Yes, according to our management system, we already have a process for decommissioning, starting from strategy development and implementation, passing through planning activities, which will be done according to the decommissioning plan till the control or release of regulatory control. So we consider the decommissioning in our management system throughout the life cycle of decommissioning.
Thank you.
Any other questions?
Are there already some considerations on the end state after decommissioning?
I don't have information about the end state. Any other questions? Thank you.
Thank you.
I'm still Natalia Sarkozy from Hungary. I work for the Hungarian Atomic Energy Authority at the Waste Management and Research Reactor Oversight Department licensing section. We are mainly responsible for the supervision and regulatory activities related to research reactors, radioactive waste storage facilities and repositories. It also deals with the authorization procedures of decommissioning nuclear facilities, and my main responsibilities are related to the regulatory oversight of decommissioning and licensing clearance of radioactive material from regulatory control. In Hungary, we have an operating nuclear power plant with 4 units, and we are in the process of constructing 2 1200 BBR type of units. We also have a research reactor and a training reactor. The main issues related to decommissioning and environmental remediation projects in Hungary are pretty much the same as other countries. I would like to highlight two issues, which is deciding on the decommissioning strategy, because immediate dismantling is the supported strategy by internationally, and even our licensees are into the direction of immediate dismantling, but our national program is stating that we should go into the direction of deferred dismantling, which is a type of safe enclosure. And the other problem we have is with waste storage facilities, because we do not have very low level waste storage facilities, and we are only in the process of the DGR research, site research.
So, I didn't understand. Initially, it has been immediate dismantling has been defined, and then you are shifting to deferred dismantling.
Yes.
What happened?
Good question. So, in our national program, it stated that we are going to go into the direction of deferred dismantling because of budgeting and financial issues. We don't really know how we'll have the financial support for decommissioning our now operating nuclear power plant, but our licensees are supporting the immediate dismantling, because we will lose the knowledge and experts who are now working at the nuclear power plant, who will be able to help us during the decommissioning process. So it's a disagreement.
And how this will be sorted out?
Time, which we don't have much of.
But I understand the regulatory authority pushes in favor
We
of.
do not push into any direction. We can decide on the strategy. We will just support the strategy that will be chosen, not by the regulatory body, but we will be helping the licensing process.
Okay. And in this dismantling, there is a time frame associated with that?
For the immediate dismantling?
No, for the deferred
yes,
dismantling.
20 years.
20 years.
But we will take out the spent fuel and then close for 20 years.
You defuel the reactor,
Yes.
and this go to dry cask as well.
No, no dry cask. We would like to go to the deep geological repository, and we are in the process of the site research. It's been like 20 years when we started, and it's too expensive. But in Hungary, people don't like to see waste above the ground. If it's under the ground and they don't see it, they don't fear it.
But realistically, what is your feeling? That is it achievable, the geological disposal, or it's more likely that you have a dry cask disposal?
I really like to say the DGR because I've been working on that for years, but it's too big of a project for us, I think, and we don't have experience on that as well. So I think dry cask will be
the way to go. Excellent, thank you. Good.
So, Uzbekistan.
Good afternoon, dear colleagues. My name is Acopian. I'm working at the regulatory body. We have just environmental remediation project in 2 sites. There is a brief information about this. In the beginning of our project, we had some issues. It was abandoned after the mining and mining uranium, drums and tilings, seismically active areas from the regional waterways, which create risks for population and environmental increased impact, radioactive and toxic materials, negative impact on the health and socio-economical well-beings, and unless remediation is undertaken, that is release of radioactive and toxic contamination will be unavoidable. And after that, we create some objectives, which is environmental remediation of uranium legacy sites in accordance with international standards and best practice, reducing risk on acceptable and sustainable levels, contributing to the implement of health, socio-economical conditions, and attractiveness of this area. Contributing to the stability and the safety of region, creating a large and more sustainable critical mass of knowledge and expertise for remediation its safety regulations. And after that, we create some strategy. There is a few informational strategy, adopting the systematic and integrated and harmonized approach that will contribute to achieving stability and sustainable development, stakeholder engagement to ensure the maintained consistency plans and national strategy, evaluating remediation options and implementing the preferred option consistent with national requirements, prioritize approach that will address the risks at the uranium legacy sites in the holistic and integrated approach, options that minimize the needed for long-term human intervention to maintain their effectiveness. And currently, in that time, we in the beginning of our project, we by support European Union's instrument for nuclear safety cooperation, including the cost estimate. We create some environmental impact assessments and feasibility studies by the European EBRD and European Bank Reconstruction Development. We have framework agreements, and in this bank create some environmental remediation account, which covering all Central Asian countries, and we establish a portfolio of project ready for implementation. And last year, in April month, we start our environmental remediation project. After that, currently there is almost final stage our remediation project. We have some challenges which related with post-remediation monitoring, observation, and institutional control after remediation project. There is some points, the development of appropriate rules for licensing, environmental remediation and exemption of sites from the regulatory control, establish long-term post-remediation management and monitoring programs, and meet other international obligations. Appointing operator for these two sites for which assume responsible for establishing monitoring and oversight programs, also provide long-term safety and land use management after the rehabilitation activities. Identify a reference laboratory able to implement radiation monitoring programs, provide quality control procedure for the analytical measurements, and coordinate the implementation of monitoring oversight programs, legacy sites, and designate operators should define measurements, which sampling and analytical methods, also data transfer for the management procedure to ensure the required quality of performance. Create of comprehensive database with information which on the remediation project, hydrogeological, radiological, and chemical conditions of the legacy sites. And it's important to harmonize our procedure for the exchange of sampling and analysis data, also inter-laboratory compares of results from the laboratory that carry out monitoring programs. So, thank you.
Questions or comments?
So you mentioned the creation of an organization somewhere, ULS operator, that will assume responsibility. That would be a governmental organization, right?
Yeah. We, when we start our project, we create some units, project management group, which under the environmental committee. Now, and now we assume they wants to will be operator in the future.
So different operators for different sites?
Yeah, this PMU transfer to operator after the complete our project, after remediation.
And what kind of monitoring will be going on? Do you have an idea?
Now we create some positions which laboratory will include because PUBU didn't have some special laboratory. We just, I think, we will encourage other laboratory under the Minister of Health, laboratory under the Minister of Geology, which they have. We includes.
Yeah, but what kind of parameters are you going to monitor?
Now we measuring the beta emitting gamma survey in this region in water but our laboratory 2 months ago we hosts two experts from the agency which they study, which are looking at our laboratories, and they had some decision because they had some decision about our laboratory not our current laboratories is not compared as not suitable for doing the future. That after that we planning to create some maybe another laboratory, maybe current laboratory, and we plan to purchase some equipment for doing in this area for monitoring.
Okay. Okay, thank you.
Which is this presentation? Country is not mentioned.
Open it, you want to see.
You don't see it, sorry. Someone recognizes it, please?
Tyler.
What happened? Yes, Tyler, it's written.
Good afternoon, everybody. I would like to introduce myself again. My name is Anand Omani from I'm a nuclear scientist from radioactive waste management from Thailand Institute of Nuclear Technology. My answer will include radioactive waste management, measurement of radioactivity in the liquid radioactive waste before and after treatment, characterization of radioactive waste before and after treatment, and environmental radiation monitoring. I was assigned to work on radiological surveillance in environmental parameters, especially in the soil and water around the radioactive waste storage facility. It's a routine radioactive waste. Yeah. Okay. This is in Thailand we don't have the nuclear power plant, but we have the one research reactor, very old, but still working now. And this is routine work. We sampling around the sample around the radioactive storage. The result, first we don't found the artificial radionuclide. Yeah. And in the parameter gamma, cross alpha beta, activity, and tritium. Thank you.
So, what are you really measuring?
Measuring?
What are you really measuring in your monitoring?
Yes, we measuring the gamma. Yes, gamma activity, gamma spectrometry in soil, water, and for that, and air. For water, we measuring by cross alpha beta activity, but we slow it down and tritium and IAEA. You know, we don't have the experience about the decommissioning because we have the plan to decommission our facility now.
But this storage facility is already in operation?
Yeah.
And it receives waste from medical applications?
Radioactive waste, right?
From what? From where?
From industrial, from medical, because from medical, because number 4 we kept the SRS. And number 3, we get the waste packet from treatment, about 200 gram, 293 gram in the future, now. We sampling the soil, water around facility. We do for baseline, for preparing for activity in the future and answer conflict.
Okay.
Thank you.
Thank you very much.
Okay, so hello again. My name is Alexandra Leisoiu. I'm from Romania and I'm working at the Romanian Nuclear Regulatory Authority within the Nuclear Fuel Cycle Division, Radiation Protection, Radioactive Waste and Transport section. So regarding the decommissioning, we had a successful decommissioning project. The decommissioning of the VVRS research reactor was completed in January 2020, and the building of the decommissioned reactor will be reused for other experimental area in the nuclear field. In terms of environmental remediation project, these are our main sites: the oil and natural gas industry and the phosphate fertilizer industry. And the main challenges are the lack of funds for the decommissioning and remediation project. We also need screening on the Romanian territory, which includes all the industries. And also there is and was a lack of understanding why, as long as they work without anything happening, now radiation has become of great interest. Sorry. So these are all for me.
So this phosphate fertilizer industry, what kind of material is phosphogypsum?
Yes, phosphogypsum.
Do you have any information about the activity concentration of radium, for example, in the phosphogypsum?
I can search because I don't remember exactly the number, but I think 1,000 something becquerel per gram. Per kilogram, yes. I can search because I don't know the exact concentration, activity concentration.
And do you have any plans for using that material for any application? Or
no, I don't think so. For the both sites, the owner are now drawing the remediation plan, so we will see. But
for the phosphogypsum,
yes.
Is there any idea of using the phosphogypsum
no,
for any
I don't
purpose?
think so. They will use. No.
And then you was mentioned screening Romanian territory means that you expect to see some other areas that need remediation?
Yes, I think, for example, the water treatment facilities, we try to communicate with them, but they refuse to communicate with us. That's why I said that there is a lack of understanding. And also maybe the cement industry. We performed a screening territory, I think, 15 years ago, or more than 15 years. And I think it's a need now. It's a need for this now.
Very good, thank you.
So that's it.
Okay, hello everybody. My name is Thiago Navarro. I will present the work I'm doing in Brazil. I work in the INB Caldas. And I'm an environmental and civil engineer, working there for almost 12 years. And, well, so the INB Caldas is the first uranium mine in Brazil. You operate from 82 until 1995. So it's about 1,500 tons of uranium concentrate we generate in this period. And now, after that, in 1995, we stopped the production because economic unfeasibility. So we have a lower grade in this region compared to other regions in Brazil. So this is the first uranium mine. We have another uranium mine in Brazil, in the state of Bahia. And we are looking for a third uranium mine in the state of Ceará. And well, we have a lot of materials disposed in waste rock piles, 45 million cubic meter. Oh, this is the open pit, and this is one of our waste rock piles. And the main environmental liability is the acid mine drainage. So we have effluent treatment 24/7, so every day. and we treat 2.5 million cubic meters per year. So this is a waste rock pile, and we have here, it's one of the basins to send the AMD to the treatment. This is our station treatment. So we have the generation of large quantities of sludge from the treatment station, 1.5 million cubic meters, and we still generating this. So this is an estimate value. And during this period, so since 95, almost 30 years, next year, 30 years, will be completed. And during this period, an attempt was made to reprocess some materials and some development of some projects to a simple closure or remediation without the good site characterization. So that's why we are working on this nowadays. And this was delaying the proper environmental remediation. So I believe we are now in the beginning of the decommissioning environmental remediation. So, well, we have these studies today in hydrological, hydrogeological, isotopes as tracers, tritium, C14, O18, geophysical methods we are using to also to determine the groundwater quality and directions. New monitoring wells include characterization of contaminant sources. So this is our main work today to improvement in the hydrological model that we have. And this will impact almost all the structures we have, like the mining pits, waste rock piles, tailing dams, settlement basins, or storage yard. Well, beyond that, we have the activities for dismantling of the industrial plant. So this is our industrial plant. We have to do the dismantling. And another waste we have, it's a radioactive waste from IAEA São Paulo. We have almost 13,000 tons in metal drums, 20,000 drums, and 20,000 plastic barrels also. So 40,000 barrels for this, and this is how we stock this material, and we have to deal with this also. And for me, the main challenges are political. We are a company from the Brazilian government, so if change the president, will change our president and our directors, and sometimes this can be an issue. Economic, well, Brazil is not a so rich country, so we have to deal with other things. We are in development country, so we have issues. The same money to the environmental program competes with public health and security and others, education. So it's difficult for us sometimes to deal with that. And technical, we are not, a few people work with this in Brazil. So INB, the only company, the only unit in decommissioning is Caldas. The others are from other activities, like the mining and the nuclear fuel, the end of the production. So we have this challenge, technical challenge. And stakeholders engagement also is a challenge because our production was made without the participation of the society. So now we have to deal with this to improve our project of decommissioning. And well, about the some concepts I know about sustainability and circularity. Maybe it's the multi-criteria analysis. We are trying to do this after the site characterization. When we reach this stage of thinking about the decommission, we are going to use this multi-criteria analysis and reduction of waste volumes if it's possible. And we are trying to do something in situ remediation without major material movements, because there are huge volumes of materials, so maybe we are trying to do less movements. And reuse of resources. Also, we have a lot of metals in the raised rock piles, thorium, uranium, and rare earths from K2, this material from São Paulo, and also from the acid mine drainage. Maybe we can reuse this. And well, that's it. Thank you.
Questions?
I have one question. So, how do you neutralize the acid mine drainage, and what do you do with the produced sludge?
Okay. We neutralize.
Just a moment to repeat the question.
Thank you. So how do you neutralize the acid mine drainage, and what do you do with the produced sludge material?
We use lime to neutralize. So the pH is almost 3, the AMD, and you use this neutralizer to pH until 10. And this sludge, we have some in the open pit. Is this brown material where it's urianate calcium, urianate of calcium. But the most part of this is sulfate of calcium. And the others basins, this is one of them. We have 4 settling basins to improve the sedimentation. And this sludge came from the reactor here in the power plant, the station treatment plant. This water is also acid from the open pit, so there is a mixture. And I'm trying to do a new project to stop that. We have a lot of studies and projects, but thank you.
Rare earths, individual or total?
Sorry?
Rare earths. You said you associate rare earths? I'm sorry. Rare earths element.
The element? Rare earths. Okay.
Individual or total?
The rare earths, we have a lot of kinds of rare earths. In this material came from São Paulo. So it's lanthanum, praseodymium, this kind.
You separate it?
No, it's in the same, it's with another elements, like uranium, thorium, it's not separate. And we treat this like a radioactive waste, but there is an economic potential. So it's a lot of discussion with this in Brazil, like it's a residue or it's maybe a product, sub-product.
Anyone else? Let's not let the horse speak for hours.
Thank you.
Thank you very much. Indonesia.
Good afternoon, everyone. I'm glad to be here. My name is Tito Baskara Adimeda. I'm a researcher at Research Center for Nuclear Material and Radioactive Waste Technology in National Research and Innovation Agency of Indonesia, or we call it BRIN. The main task of the institution is to research in nuclear fuel technology from the upstream to the downstream and radioactive waste, including pre-disposal technology for radioactive waste treatment, including decommissioning and environmental remediation. Actually, I'm a geologist. I'm experting in characterization of rocks and uranium minerals. So I'm not really familiar with D and ER, but I think this is my experience that can be related to the NER is the equipment. I use radiation monitoring equipment such as gamma spectrometer and radon monitor in uranium exploration, but I think it can be related to the D and ER in the future. This is the main challenge related to the NER in Indonesia. So Indonesia has 3 research reactors that has been active for age, and maybe one of the reactor is planned for decommission. This reactor is planned for decommission. So this is maybe the first experience in Indonesia. We have to prepare resource, prepare funding, and regulation. I think this is the challenge we will have in the future. And also about this is a new idea I get from the house presentation this morning. Indonesia is the biggest tin production, and the tin is associated with so many uranium minerals, and it is creating a big amount of norm. So this is the main challenge: how to we manage the norm and the environmental, so it's safe for everyone. Thank you. Any question?
Questions or comments? First?
No, yeah. Very familiar.
Well, thank you very much, then.
Thank you.
Is there anyone who had a presentation and did not have an opportunity to present? No? So then first I think.
Yeah, we have a
So we have a coffee break for 3:30. Let's try to respect that. I just wanted to make some notes. We will be presenting this in a more consolidated way. But you could see one important point when you don't plan the commissioning in advance. We face issues like was reported here for the lack of funding to address the decommissioning, because the decommissioning will definitely cost money. Some estimates for one reactor, 1 megawatt reactor, gigawatt reactor, goes to $1 billion. So you need really a lot of money to deal with that. We also need solutions for the waste that needs to be taken care of, particularly the spent fuel. So we were listening from Hungary the fact that deep geological disposal is definitely one of the most validated solutions for the waste, but it takes not only money, it takes time to define the proper site, but also to get public acceptance. I appreciate the fact that you said that if you don't see that, then it's easier to get acceptance, but it's a very long process. So this is something to keep in mind. And then if you don't have the resources like in Iraq as well, that was pointed out, you go for the safe enclosure or entombment. That is about procrastinating the issue for the future. So this is something that we could learn. So when my colleague in Jordan said, no, we may need decommissioning, definitely you will need decommissioning, and you need to design your operation with the decommissioning of the facilities in mind, with a closure plan for the mine and for the waste that are generated, because the problem in the past is that those things were considered the marginal costs to the project. They were not put in the cost of the project, right? And then when the moment comes, you don't have the resources that should have been generated with the selling the energy, if in the case of a nuclear reactor, or if the uranium ore in the case of a mine. And then, as Thiago mentioned, there are other priorities in a country to allocate money for, particularly when this is state-owned companies, and definitely you will need to dispute money with that other priorities. And moreover, the point is that as much as you take action on these things, the structures that you deal with, they start to deteriorate and the costs start to accumulate. For example, Thiago talks about acid mine drainage. Acid mine drainage is a natural process that includes the oxidation of pyrite, but air and oxygen produce acidic waters in pH of 3, 2, and remove contaminants from the rock. And then you cannot release this water into the environment. You need to treat the water before the water is released into the environment. The point is that he presented the amounts of waste that are generated and they are now pumped into the mine pit. So you create another disposal site that you need to take care of. And moreover, when we discuss about treatment of mining waters, I always say this phenomenon will take place for decades and sometimes centuries. And you cannot envisage treating water for such long periods of time. You need a more definite solution. All in all, if all these costs are included in the feasibility study of the project, you may conclude that economically it was not feasible to produce uranium in that particular site because the cost associated with the closing of the mine and the commissioning of the facility will be outweighed the money you could recover from the production of the ore. But then we go in another discussion. This was something that was started decades ago, and the decision of the government, and I can speak about that because I know the story, is that it was strategic for the country to produce its own uranium and do not have dependence on external sources. And when you decide that something is strategic, the economic consideration goes away because there is something in the views of the decision makers that is more important than the economy. Also important is the long-term monitoring of these things, because there are some remediation activities that are not walk-away solutions. You know what walk-away solutions? That you just walk away. It's done and game over. That's not the case, because you will need to check for the performance of the engineering solutions in many cases. For example, if you use covers, which is a very wide approach to isolate wastes, like in tailings dam, in tailings pile, I think that is something that's done in Uzbekistan, then you need to make sure that the cover is there. And the radionuclides in the tailings, like radium-226, it has a half-life of 1,600 years. And the erosion of these covers will imply that the cover will lose its efficiency much sooner than the amount of radium decreases significantly in the tailings. So you will have to have dedicated operator to take care of that. And you ask me for how long this will be the case, that we will have to treat, to control these objects forever. That's the answer. That's forever. Because the half-lives of the radionuclides involved in these materials are very high. Or you can choose to construct superstructures that would hold for 10,000 years, which is something that is adopted in some countries, and you end up with something that is really, really very, very expensive. The good news, if there is any that we can share, is that some of these materials, and this is where our conversation comes into play, some of these materials may not be treated as waste. For example, in the case of acid drainage, I have done some calculations in the past, and you can extract uranium from the acid drainage, right? Because the leaching process of a uranium ore that you have in a milling facility is essentially attacking the ore with sulfuric acid to remove uranium. And acid drainage is essentially sulfuric acid leaching metals, including uranium, from the rock. So you will never justify a mine by meaning of treating uranium, recovering uranium from the from acid drainage. But once the problem is already there, you may have a kind of analysis if you can take uranium out of the acid drainage and make some money with that, and money that you can reinvest in the remediation of the site. This is our next course in South Africa, when we talk about costs of decommissioning and remediation. And we will see that in South Africa there are a lot of tailings around Johannesburg with different types of metals that would be eventually reworked, and that includes rare earth and others and other metals. When I spoke about phosphogypsum, which was that one, was Romania. Phosphogypsum can be used in different applications: soil amendment, building materials, constructions of roads. So it makes much more sense to use the phosphogypsum in those applications, depending on the activity concentrations. This is why I ask you about the concentrations of essentially radium in phosphogypsum. Then instead of treating this as waste. So that's bringing a different thought of valorization of residues. I'm calling residues, I'm not calling waste. Valorization of residues in the scope of what we call the circular economy. And last but not the least, the same thinking can be applied for the site. And I will discuss this, if not today, I think it's tomorrow, following the presentation of Giuseppe, is to bring the site itself for second use. Instead of leaving the site fenced without no use, you can imagine to bring the site for second use, as the French speak, second life for the site, or the way I like to put it, turning legacies into assets, turning a liability into a way of making money that can be reinvested in the remediation of the site. So I guess that this was all elements that were in your presentations that gave rise to a lot of these considerations, and our challenge will be to demonstrate how these concepts can be applied in the sites, in the facilities you have in mind. But keep in mind those things that I talked about. The long-term circumstances that you have to manage, the need to plan for those who are embarking, need to plan the commission, need to plan potentially remediation already in the beginning. So adopt good practices that would not lead to new legacy sites, This is very important. And the aspect of thinking of valorizing what is being called as waste, but can be put into beneficial use and eventually make money with that. And also contributing to reduce the pressure on the natural resources that would be the equivalent for the materials that you are valorizing by means of taking metals from there or using the material itself. Is it clear? I think that this brings a good context for what you will be dealing during this week. But important thing that funding will always be a problem for these situations. Funding will always be a problem. It will always be on the side of the government to fund this project. And when we talk about government, there is no government money. There is public money, taxpayer money. So this is where the money comes from. And this money will always, particularly in countries like mine, where we have other important priorities, this money will compete with other priorities that need to be addressed. Of course, that when you think about the only the problems of the US DOE with the Manhattan Project. Manhattan Project was a project that was implemented to produce atomic weapons. We are talking about $300+ billion just until 2030, and I think this is more, only for US DOE sites. But it's a different economy. This is a different reality. But when you think about those things in the context of economies that are not that strong, then you have a big problem, and the solution will always be pushing it to the future. But that solution is not very effective because you will also be dealing with escalating costs, and the cost of maintenance over time need also to be considered. Of course, that many people will think that instead of investing money for a solution for a problem right now, which will amount to the millions, I will keep drinking water for decades. When you integrate the cost over this long period amount of time, you will see that you spent quite a lot of money. But it's always easier to spend a small amount of money in short periods of time than making a big investment to solve the problem. But this is something that has to be addressed and eventually try to get innovative solutions, like I mentioned, or try to get agreement with the international funding organizations to solve the problem at once. Okay? Just some very highlights of what you showed us. It's not anything that I had before, but that was essentially insights from your own presentation. So let's make a break and we come back at in 20 minutes. All right? Thank you.